Hey y'all, welcome back. We just got done talking about how things that don't change in your perceptual field do not get registered. We don't see things if they don't change. Okay, now let's talk about how perception is not entirely veridical. We should probably talk about what veridical is first. Veridical means truthful, right? Veritas, for those of you who took Latin in high school. Right? So veridical means truthful. So things that aren't truthful in perception are perceptual illusions, right? And we know we're most familiar with perceptual illusions because of what we call optical illusions. These are not optical illusions, these are perceptual illusions. There is a difference. Okay. Now, this particular illusion is a pretty famous one. It's called the lilac chaser. So what you want to do is you just want to fixate on that cross. Just look at this center cross here and look at the center cross, okay? Don't let your eyes follow any kind of other motion. You're just going to stare at that cross. Now, what you should be seeing as you stare at that cross is a green dot. Okay, you see purple dots in a circle, and then you see a green dot moving around that circle. And eventually, as you're staring at that cross, the green dot sort of like eats all the purple dots up, and the purple dots disappear, right? Okay, you look away a little bit, the purple dots come back, but then, oh, they disappear again. All right. So that's essentially what's going on in this image, what you should be seeing. The fact is that um, there's there's no green in this picture. Green does not exist in this picture. The color green is not here. Okay, what you're seeing is an after image of purple. Okay, so when the purple dots disappear, those neon purpley dots, you get this neon green dot. Okay, this is called opponent processes. Okay, so green and red, in this case, green and neon greenish and purplish, right? They're opponent colors. So what happens is that receptors that signal red get pretty strained. And when that red goes away, everything needs to come back into balance, right? So it's just like our nervous systems. We have the sympathetic nervous system that takes us into fight or flight, and then the parasympathetic comes back in and evens everything back out. Same thing with opponent processes. You've got red registering, right? And then the red goes away. Well, let's put in green to cancel out that red, but we overcompensate a little bit, which leads to a color after image. Okay, this is the same concept as, hey, look at the picture of this flag. Just stare at the picture of the flag, and then you look at the white wall, and oh, you can see that it's an American flag in red, white, and blue, even though I was looking at this really crazy colored picture of a flag before. Right? That's all after images. Okay, so number one, there's no green in this image. Number two, there's no motion in this image. You are perceiving motion, you're interpreting motion because things are disappearing, right? So the purple dots are disappearing one by one, and because their disappearance leads to the appearance of a green dot, what you're actually seeing is a green dot appearing in spot after spot. So it looks like a green dot is moving in this picture. Okay? And the last thing that isn't actually there is the disappearance of these purple dots. They're not supposed to disappear. They never actually like disappear completely all at once, right? They disappear one at a time, which leads to your green dot, but they never disappear all at once. That's just the image stabilization happening, right? So we have the apparent motion, your perception of motion when there is none. We have the image stabilization on the retina, which means the image goes away. Okay, so lots of things happening in this particular illusion that just aren't real. You've seen this one already, right? We saw this in our vision lecture. We saw receptive fields, how they make the black dots show up in the periphery, but when you look right there in the center, there's nothing there. We talked about this being a result of our receptive fields, right? There's not a lot of difference in what's happening with cell activation here and here, right? They look pretty much the same, but here you've got a lot more. You've got a lot less inhibition going on because you have less activation of an inhibitory surround area, right? So this appears more dark. This appears more darker. This appears darker, right? Because there's more inhibition lit. Like these areas here that are inhibitory are more lit up. So this is darker. This guy. This is all about peripheral drift, right? So the type of gradient used in the shading of these snakes. So you get like a strong delineation versus a weak versus like a smooth gradient. This tricks our motion detectors. Okay, so when texture is played with, you start to get motion. There is no motion happening in this display. Okay, it's just your visual system. Or this. Okay, well, what's so special about this? It's just a big spiral. But it's not. This is called a Fraser spiral, and it's not a spiral at all. It's actually concentric circles. So, I actually have an animation here. Oh, I thought I had an animation here. Let's try this again. So we'll put the stars there, and then I'll show you. See? We'll start at this star. I am tracing the line all the way around to that star. Hey, look at that. It's a concentric circle. We'll start at that star. And we end up at that star, right? Concentric circles. It is not actually a spiral. So, is this cat going up or down? Who knows? Looks like he could be coming down the stairs. Looks like he could. My first interpretation is he's coming up. But it really looks like he could be coming down the stairs too. You're at the bottom of the stairs looking up, or you're at the top of the stairs looking down, right? Ambiguous. The point of all this is that our perceptual systems have adaptively evolved, okay, for survival, right? Some of those adaptations in very special situations will do us wrong. Okay, so this idea that if it doesn't change, you're not going to perceive it, right? That is all in an effort to sort of reserve our cognitive efforts. We only want to pay attention to the things that are really important, and the things that are important are the things that are changing in our environment, okay? So that's an important evolutionary change of our perceptual system, an important evolutionary adaptation of our perceptual system. But you could see in the case of the lilac chaser, okay, it does us wrong because things disappear, right? They go away in particular circumstances. So when we study illusions, we can sort of figure out, like, okay, how is our visual system doing us wrong here? And by understanding how it's doing us wrong, we can sort of figure out how it's supposed to work, what it should be doing to work correctly. Okay? Okay, so that's how perception is lying to you, how it's not entirely veridical. Next, we'll move on to perception takes time.